We're going to continue our discussion of feature engineering, where you have a problem and you slowly add features to a data set to improve your performance on some downstream task. Last time we talked about classification. This time we're going to be talking about regression. So in this case, let's say that we have a bunch of homes, and we know how much a house was sold for in 2007, and how much it was sold for in 2013. And the important information here is that in 2007, house prices were really, really high, at least in the United States, and in 2013, in many places, they went down quite a bit. There was a housing market crash. And we want to predict, given how much a home cost in 2007 and where it is in the country, how much it's going to cost in 2013. So we can start with just a super simple model where we're just going to do a simple regression with only one feature, the 2007 price. And so if we do that, we get an error of around 4,000. And that is pretty bad because all of our prices are in thousands of dollars. And so we're making a huge error if we just use that information. So this is all squared errors, so we're taking our errors and squaring them. So this is still a pretty big error, and we want to get that down if at all possible. So let's try to take a look at where we're having issues. So we can plot the price in 2007 on the x-axis, and we can plot the error on the y-axis. This is called a residual plot, and this is a good way of diagnosing where you're having problems. And so as you can see, that the bigger the price is on 2007, you get a much larger error. And so something weird is going on with these prices, and we're doing particularly poorly on the expensive houses. So let's add in the square of the 2007 price, so that if you have a really expensive house, it's going to make this feature, the squared price of the 2007 price, really, really big. And so now the regression can capture expensive houses a little bit better. And so if you do that, the error comes down quite a bit, and so our error goes from around 4,000 to around 3,000, which is a big improvement. Okay, now what if you add in states? And so not everything in the United States is the same. Different states are different. So let's add in the states as well. And so now if you do that for all of the states, you can start seeing some interesting properties. And so if you add in states as an additional feature, you now have a feature that kind of encodes how much a state was impacted by the crash. And so if you look at, say, Florida, that was hit really hard by the crash, and so it has a big negative coefficient. If you look at Texas and Colorado, they weren't hit so hard. Prices were almost flat. And if you look at Alaska, Alaska actually had an increase in prices from 2007 to 2013, and so it has a higher increase. So with that, we now get our error down even further to in the 2000s. So now let's move on a little bit more. Let's now try to use poverty information about the individual counties where these homes are being sold. And so here we do this by looking up some government data, and we add an additional column to our data set that encodes what percentage of the people in this county live in poverty. And if we do that, the error doesn't really change very much at all. So that wasn't too useful, but it was worth a try. And in fact, the development error actually goes up, so it's actually hurting us, which is the wrong direction that you want to go. So the way to think about this is that states are too big and counties are too small. And is there something that we could do to capture something in between? So we do have the zip codes, and individual zip codes aren't very useful, but the structure of the zip code tells us some information. So For example, if you take all the zip codes that start with the number 8 and plot them on this map, you get basically the western states minus California. And the coefficient, if you add that in as a feature, is 51.9. So this shows that this area did relatively well during the crash. And so prices in this broad region went up. And if you look at the first two digits, 80, that corresponds to a big chunk of Colorado. And so again, prices went up here as well. And you can even go even further, 803, and that's basically the front range of Colorado. And here we can't get any smaller than this because there are missing 3-digit zip code combinations that aren't in our data set, and then we would have to do something fancy to fit that in. But the first two features actually do help us a bit and get our error down to just about 2,000. So before we were a little over 2,000, now we're right at 2,000. So now we've gotten our error down quite a bit, and there are probably other features that you might want to try out on this data set. So feature engineering is not just for classifications, it's also for regression, and basically any supervised learning task. We'll next talk about a final example of feature engineering, looking at trying to detect spoilers on the internet.